All right, so we're gonna go through these answers, and then I'll take some questions, and then we'll take your quiz, okay? The quiz is just gonna ask you to identify how to prove that a parallelogram is a parallelogram, and you can use your notes for that part. Okay, that part should be simple, easy points, and then you'll have to do 3 calculations like this, okay? So the first question is distance formula. Like, how would I prove that these coordinates on an XY coordinate plane are actually a parallelogram? One option is that I would prove that all the sides, or that the 2 opposite sides, are equal in each case, right? So let me diagram this first, and then I'll show you what I mean. Hopefully this is not new. This is just review at this point. So let's diagram it. Let's say that this is the origin. We'll go back 10 and down 2. Let's say that this point right here is Q. All right, so I'm just roughly graphing it. This isn't an accurate graph, but it's going to give me something to work with. So then I'm going to go over 1, down 1 for R. So that, let's say that's here, that's R. And then over 1, down 7 for S. So there's S. And then back 11 and down 8. So this is T over here, okay? So let's say that that is the way it's organized, and I'm just going to connect these lines up like this. Here's my parallelogram, or at least it could be a parallelogram, right? So this one is Q. So what I'm looking to do is to prove that this side right here is equal in length to this side. So QR, the segment QR, I'm looking to prove that it's equal to the segment TS. If I can do that, if it does come out that they are equal, then I also have to prove that RS and QT are equal. I have to do both to be sure. On the other hand, if the first one I do, it turns out that they're not equal, I'm finished. Because it certainly cannot be a parallelogram if I've shown that 2 sides are not equal in length, right? So let's just do the math. So we're going to use distance formula. So that would be the first one we're going to do is going to be QR. So the distance between Q and R is this. The square root, I'm using these data points right here, Q and R. So it's going to be the square root of -10 minus 1 squared plus, okay, so I got -10 from right here. Let me just grab my pointer. Where's that thing? Yeah. So anyway, right here, that's the x coordinate, right? And this is the x coordinate. So we're just subtracting these 2, and then we're gonna square it and then add it to the difference between the y's. So this point right here, -2, and this one right here, -1. So it's gonna be -2 minus a -1 squared. So this part comes out to -11 squared, that's 121. And then I'm gonna add that, this minus a minus, that means plus, basically. So it's -2 plus 1, that comes out to -1. When you square -1, you get 1. You get 1. Anything squared, if you take 2 numbers that are negative and you multiply them, you get a positive. So if you square a -1, you get 1 out, positive 1. So then this is going to be the square root of 122. That's the length of this side, square root of 122. With me so far? So now I'm going to do T and S. So let's do the math for T and S. So the distance for T and S, that's equal to the square root. In fact, let me just do this in blue and highlight these points over here. So we're doing S and T now. I'm looking for the distance right here, T and S. So the distance from T to S, that is the square root of 1 minus 11 minus, yeah. Oh, no good? Which one, this one?
The blue one.
The blue one, okay. I got you.
Mr. X. Thank you.
Okay, all right. Whew, try not to let your OCD control the class, okay? So, look, 1 minus a minus 11, we're going to square that. We're going to add it to -7 minus a minus 8. we're going to square that. So when you do 1 minus a minus 11, that comes out to 12. If you square it, that becomes 144. And do I have to keep going or can I stop? I can stop because it's very obvious that this number is never going to be this number. So this is certainly not a parallelogram. And I'm finished. If it came out that they were equal, then I would have to do the sides RS and QT and compare them. And if they were equal, then it would be a parallelogram. Yep.
I have a silly little question. Why don't y'all put the parentheses around the second negative number? Like in that parentheses right there, if you see two negatives, why don't you just like close the parentheses? Like right there, I don't know.
Yep. Yep. On the negative 11?
Yeah.
Why?
So why don't you do that?
Because negative and negative, that's just positive. So it's just 1 plus 11. It's 12.
I'm just saying that just use it to where it multiplies the negative into the number that's in that slot, instead of just saying.
Because it overcomplicates it. It's just an overcomplication.
Looks better.
It's not all about looks, okay? It's not all about looks. All right, yes. All right, so let's try the slope. So I'm going to diagram this again. All right, so let's diagram this one. Let's imagine that this is our origin right here. We're going to go back 4 down 2, that's P, right? Or sorry, back 4 and up 2, that's P right there. And then I'm going over 6 and up 4, so let's say this is Q. We're going over 11 and down 2, let's say this is R. And then over 2 and down 3, let's say that this is S. All right, so that's not very accurate, but I'm just going to use this to try to keep my mind on what I'm doing. I want to have some kind of a logical framework from which to work here. All right, so here's my parallelogram. And what I'm going to do is I'm just going to compare the slopes of either of the opposite sides. Okay? And so I'm going to start with P and Q. So let's do the slope for P and Q. Or rather for the segment PQ. So the slope of PQ, that's equal to the difference between the y's over the difference between the x's. So here are the points. So it's going to be negative 4 minus 6. All right, so negative 4. Is that how it goes? Negative 4 minus 6. Is that what? Am I doing it right?
It's the Y.
Ah, so the most common mistake is to put the x's on top, right? So then it's really going to be 2 minus 4, and we're gonna put that over 6, or rather, I'm sorry, minus 4. Hey, stop interjecting. You're messing with my head. All right. So 2 minus 6. I'm sorry, 2 minus 4. That's what I've got written. Okay. And then negative 4 minus 6. Negative 4 minus 6. So on the bottom, I'm recording right now, so your voice is going on YouTube. Uh-oh. Zip it. All right. So this comes out to, this is for everybody who misses class, okay? It's for them, so just follow along. So negative 4 minus 6, that comes out to negative 10. And then on top, it comes out to what? This is where you can talk.
No, 2.
Negative 2. So let's call this then 1/5. All right? So a negative divided by a negative, that comes out to a positive. You with me? So now that I've got the slope for PQ, I'm looking for the slope for SR. So the slope for SR, let's do that in blue. So slope for SR, that'll be, we're going to work with these two coordinates right here. So it's going to be minus 2 minus a minus 3 on top. Minus 2 minus a minus 3. And then 11 minus 2 on the bottom. 11 minus 2. So if we don't screw up the arithmetic, negative 2 minus a minus a 3, what is that? So this is like saying plus 3, right? So that's 1. And then on the bottom, 9. All right. So compare the slopes. Are they the same? No. Lines that are parallel have the same slope, right? What if they were perpendicular? What would their slopes look like?
Opposites, so if it's like 9/1, it'd be
You'd flip it, right? Exactly. So if they were perpendicular, they'd be negative reciprocals. You'd flip the number and make it negative, or change the sign anyway. All right, so these two are not parallel, so it's not a parallelogram. All right? Okay. And then let's do number 7. We'll just do some midpoint. All right, this is my last example, and then we'll take the quiz. So let's diagram it. Let's say that this is the origin. We're going to go back to down 9. So let's say that this is B at the origin, and then down 5, let's say this is C. And then let's say we go over 6 and down 3. This is going to be D. And then E. This one you got to be really careful with. I messed this one up last time. And it looked like a triangle. Okay, try it again. So back to down 9. Let's call this B down here. At the origin and down 5, let's call that C. And then over 6 and down 3, that's D. And then over 4 and down 7, that one's E. So then thank you, Anaya. So if I'm going to connect all those up, that's my origin. She just wants to be famous. She knows this is going to go viral. She's all like, wanting to be. Okay. So anywho. So here's my quadrilateral. All right. It's ugly, but it's going to do the trick. When I'm doing midpoint, the reason I drew the diagram is because I want to make sure I do the right, I work with the right numbers. So I'm looking at the diagonal and how they intersect. So I actually am looking for CE, okay? So this is C. We're looking for CE, and we're looking for, let me do it in green, BD. And what we're looking for is to see if they actually bisect each other when they intersect. So that would make it so that they have the same midpoint. So then let's do the midpoint for CE. So the midpoint for CE would be like this. You're going to take the average of the x's. So we're doing C and E. So that would be 0 and 4. We add them together, divide them by 2. So 0 plus 4 divided by 2. And then -5 plus -7. -5 plus -7 and divided by 2. It's just an average. So you're always dividing by 2. Thanks. So then 4 divided by 2, that's 2. And then -5 plus -7. Come on. It's going to be a negative number. You said -6 after you did the division, right? But up top, what does that equal? -12 divided by 2 is -6. You're right. I see what you mean. Okay. So there you go. That's the midpoint for this first diagonal, CE. The midpoint is this point right here. So let's do the midpoint in a different color. Let's do the midpoint for BD. BD. All right, so that's going to be equal to the average of the x's and the average of the y's for these 2 points. So it's going to be -2 plus 6 over 2. And then -9 and -3 added together divided by 2. So let's just do that math, okay? So -2 plus 6, that comes out to 4. You divide that by 2, you get 2. So that'll work. And then -3 plus -9 plus -3 is -12. Divided by 2 is -6. So is this a parallelogram? Yes, this one is a parallelogram because those diagonals actually do bisect each other. They share one single midpoint. Do I have to do any other math to prove that it's a parallelogram? This is it. So if I had a choice, if I were doing some of these problems and I had a choice of what method to use, I would always pick midpoint myself, just because I only have to do 2. I'm sure I only have to do 2 calculations. And I find taking the average to be a little easier than doing like distance or something like that, because you have that radical. Okay?